Nitrite ion NO2 minus. Total number of electrons will be equal to 5 plus 6 plus 6 plus 1. Since it is anion, you should add 1. So we get the total number of electrons as equal to 18. Next, show nitrogen at the center and oxygen on either sides of nitrogen. Each oxygen atom has 6 valence electrons. Since it is anion, the extra electron is shown along with nitrogen. So you will find 6 electrons around nitrogen. Both oxygen and nitrogen requires 2 more electrons to get octet configuration. So both oxygen and nitrogen will contribute a pair of electrons for sharing with each other. Therefore, a double bond is formed between that oxygen atom and nitrogen. The octet is complete in the case of nitrogen. So nitrogen contributes a pair of electrons for sharing with the other oxygen atom. So that is why a single bond is formed between nitrogen and the other oxygen atom. The electrons which are not involved in bonding, that is lone pair of electrons, are shown separately. Now 3 minus. Total number of electrons will be equal to 5 plus 3 into 6 plus 1, which is equal to 24 electrons. You can show nitrogen at the center and 3 oxygen atoms are shown on 3 sides of nitrogen. Each oxygen atom has 6 valence electrons around it. Nitrogen has originally 5 valence electrons. But since an electron is added, that extra electron is now shown with nitrogen. So that is how we get 6 electrons around nitrogen. Now consider nitrogen and any one oxygen atom. The oxygen shown on the right hand side of nitrogen. Both nitrogen and oxygen requires 2 more electrons to get octet configuration. Therefore, both nitrogen and oxygen will contribute a pair of electrons for sharing with each other. Since 4 electrons or 2 pairs of electrons are shared between nitrogen and oxygen, a double bond will be formed between nitrogen and that oxygen atom. The octet is now complete in the case of nitrogen. So nitrogen will contribute a pair of electrons for sharing with the second oxygen atom, which is shown on the left hand side. Thus, a single bond will be formed between nitrogen and the second oxygen atom. Similarly, nitrogen contributes 1 more electron pair for sharing with the third oxygen atom. And that is how a single bond is formed between nitrogen and the third oxygen atom. Ammonium ion NH4+. The formation of ammonium ion can be shown as ammonia NH3 plus H+, that is proton, gives ammonium ion NH4+. Total number of electrons will be equal to 5 plus 4 minus 1. Since it is cation, it is minus 1. Thus we get 8 electrons. Nitrogen is shown at the center and 4 hydrogen atoms around it. Note that out of the 4 hydrogen atoms, 3 of them have 1 electron each. The 4th hydrogen is shown as a proton. It has no electron. Nitrogen has 5 electrons around it. A pair of electron is shared between nitrogen and 3 of the hydrogen atoms. Thus, 3 NH bonds are formed. The 4th NH bond is formed by the contribution of a pair of electrons by nitrogen for sharing with the proton. Next, we shall learn about formal charge. How can we calculate the formal charge on an atom? Formal charge on an atom is given as equal to valence electrons in the free atom minus non-bonding electrons minus half of bonding electrons. Non-bonding electrons means the electrons which are not involved in bonding. Bonding electrons are the electrons which are involved in bond formation. For example, consider ozone. The Lewis electron dot structure is shown, from which you can get the number of bonding electrons and non-bonding electrons in each oxygen atom. Consider the oxygen atom with 2 non-bonding electrons. What is the formal charge on this oxygen atom? It will be equal to number of valence electrons, which is equal to 6, minus non-bonding electrons. 2 electrons are not involved in bonding. So now non-bonding electrons will be equal to 2 minus half of bonding electrons. You can see 3 bonds around that oxygen and each bond requires 2 electrons. So that gives a total of 6 electrons. So there are 6 bonding electrons since 3 bonds are formed by that oxygen atom. So half of 6, that gives you 3. So the formal charge will be equal to 6 minus 2 minus half of 6, which is equal to plus 1. Now consider the next oxygen atom with the 4 non-bonding electrons. The formal charge will be equal to valence electrons, which is equal to 6, minus non-bonding electrons, which is equal to 4, minus half of bonding electrons. The bonding electrons in this case is equal to 4. So that gives a formal charge as equal to 0. Now consider the next oxygen with the 6 non-bonding electrons. In this case, the formal charge will be equal to 6 minus half of 2. So the formal charge will be equal to minus 1. Consider the next example, nitrite ion NO2 minus. The Lewis electron dot structure is given, from which we can get the number of non-bonding electrons as well as bonding electrons present with each atom. Consider the first oxygen atom with the 4 non-bonding electrons. What will be the formal charge? It will be equal to valence electrons in oxygen is equal to 6. So 6 minus non-bonding electrons is equal to 4. So 6 minus 4 minus half of 4. A double bond is present between oxygen and nitrogen. So half of 4. That gives a formal charge on this oxygen atom as equal to 0. Now consider the nitrogen atom. The formal charge will be equal to, here in this case the valence electrons should be taken in the free atom. Nitrogen has 5 valence electrons. So 5 minus non-bonding electrons is equal to 2 minus half of bonding electrons. 3 bonds are there. So half of 6, which is equal to 3 minus 3, which is equal to 0. Now consider the next oxygen atom. Formal charge will be equal to 6 minus half of 2, which is equal to minus 1.